In this video, we're going to look at a new technique for solving equations called completing the square. So far, we've seen how to solve equations using factoring, as well as the square root property. But we've seen that not everything can be factored, and we'll find that not every equation can be solved using the square root property. And so having another technique that works in all situations is going to be beneficial. Before we learn this new technique, let's first review how to solve an equation using factoring. The first step is we want to make sure that this equation is set equal to 0, and in this particular case we already have that. So now we can factor the left side. When we factor, we first look for descending order, which in this case we have. Then we look for a GCF that we might be able to factor out. In this case, all three terms share only a GCF of 1, so we won't bother pulling anything. And then we look at how many terms there are. Here we have 3 terms, so this is a trinomial, and I'm going to go ahead and factor this using an X box. I look for the product and I look for the sum to help me find these numbers that I need for my factoring. The product is going to be the first times the last number, as always. In this case, 1 times -8 is -8. The sum is always found in the middle. In this case, we have 2. So we're looking for numbers that multiply to -8 and add to +2. Those numbers would be 4 and -2. Because there was nothing in front of x squared to begin with, we can take these two numbers and throw them right into parentheses. So my factorization will be x plus 4 times x minus 2. Don't forget that this is an equation set equal to 0. Don't forget to drop that equals 0. So now the left side is factored. It does say something times something, but when you think you're done, think again. If I tried to look at factoring these further, I wouldn't be able to do anything. Both of these are linear factors. They have no visible exponents. If they're linear, we'll leave them. And so now we can use that 0 factor property. If something times something is 0, one of these factors must say 0. Either x plus 4 will give me 0, or x minus 2 must be 0. And so that now takes this quadratic equation down to 2 linear equations that are much easier for me to solve. To get x by itself, I will relocate the constant to the other side. For this example where I have plus 4, I will subtract 4. Here where I have minus 2, I will add 2. Again, we always use the opposite sign for relocating. And so now I have x isolated in both cases. From this first linear equation, I get x equals 0 minus 4 is -4. In this second one, I have, with relocating the 2, 0 plus 2 gives me a +2. So I do get 2 solutions, which I expected because I had a degree 2 polynomial, which we call a quadratic. So now what we're going to do, now that we know what the 2 solutions ought to be, we're going to look at a new technique for solving an equation just like this one, a quadratic equation. And let's practice the new technique using this example where we already know what the solutions ought to be, and make sure it works. So we'll walk through the steps, and then we'll get several other examples to help us get some extra practice. So when we're doing completing the square, the first thing we want to look for is we want to verify that the leading coefficient is 1, and in this case it is. If you see nothing in front of x squared, you're good to start. If we don't have a 1 here, we'll see later what to do in that case. But we're able to start when the leading coefficient has no visible number in front of it. Next thing we want to do is we want to keep the letters on the left, but we want to relocate the constant to the right. In this case, the 8, which was negative, will be added to both sides to relocate to the right. So that leaves me on the left with x squared plus 2x. On the left with x squared plus 2x. On the right we have 8. So now I have letters on the left, number on the right, and this is the point where I complete the square. Notice on the left side, one of these terms is a perfect square, the other is not. What I ultimately want though is I want a situation like I saw in the last video where I had something squared equals a number. What I want is to make this left side altogether a perfect square. And there's a technique we can use here, completing the square. We're going to find a magic number that turns this into a perfect square. The way I do that is I look to the coefficient on x, I take that number, I cut it in half, and I square it. So the coefficient on x here is 2. If I take 2 and I cut it in half, I get 1. And if I take 1 and square it, 1 times itself is still just 1. 1 is going to be the magic number that completes the square. So what I'm going to do is I'm going to add 1 to the left. We'll see how that completes the square in just a moment. Remember though, if you're going to add something on one side of an equation, you'd better do it on the other side, because again, our goal is to maintain the balance as we're solving. So now on the left side, we have a trinomial, and just as we did over here, you could go off to the side, and for this trinomial, you could do an X box to factor it. If you took the time to do that, what you'd find is that the numbers that multiply to 1 and add to 2 are just 1 and 1. So when this factors, you're getting x plus 1 times x plus 1, which we could write as x plus 1 squared. On the right, 8 plus 1 is just 9, and what we've done now, by adding this magic number 1, we've now created a situation like we saw in the last video. Something squared equals a number. And when we have that set up, we can go ahead and square root both sides. We can use the square root property. The square root will make the square disappear from the left side. And as soon as that square disappears from the left, remember that a plus or minus has to appear on the right. And so I have plus or minus, and then square root of 9 is 3. So now the exponent is gone, and the only thing I have left to do to get x by itself is to relocate that constant. Since it's a plus 1, I will go ahead and subtract 1 from both sides. So now x is isolated, and remember what we want to do when we have plus or minuses involved is we want to write our relocated number first and write our plus or minus number last. And in this particular case, the 1 and the 3 are like terms. They're both nice whole numbers, and so we actually can combine them. We actually can add and subtract. So let's take a look at the plus and the minus version of this statement. Negative 1 plus 3 will give me 2, and negative 1 minus 3 will give me negative 4. And so I get two solutions here, which I expect because it is a degree 2 equation. But not only that, they match the two solutions that I got when I factored. So this technique works. Now when I look at these examples side by side, it looks like I would rather favor factoring because it got to the same answer but faster. But keep in mind that not everything factors, and so while factoring is a very fast and efficient technique, it's not always usable. So this new technique, which is not much more work than the factoring, this new technique is going to work for every single quadratic, whether or not it factors. So let's take a look at several more examples so we can practice this new technique. The example we're looking at now is actually one that would not be able to be factored to solve. I can't find numbers that multiply to 10 and add to negative 8. And so here factoring is not going to work. I can't use the square root property yet because the something squared, when isolated, will not reveal a number because there's this extra x involved. And so the factoring and the square root property aren't usable. Let's try this new technique of completing the square to see if we can get our answer. So again, the first thing we look for when completing the square is we look to verify that there's nothing in front of x squared. I just want to make sure that there's only a 1 there, and in this case that's true. So I can proceed as long as there's nothing in front of x squared. I can begin. And when I begin, I want letters on the left and the number on the right. So I'm going to take that positive 10 and I'm going to relocate it to the other side using subtraction. And so now I have the letters on the left, x squared minus 8. On the right, I'll have the constant 0 minus 10, which is negative 10. So I have letters on the left and number on the right. And this is the point where I complete the square. The left side is currently not a perfect square. There's a perfect square piece, but the entire thing is not a perfect square. And so I need to add something to the left to make it a perfect square. The way I do that is I look to the coefficient in front of x. Here I see a negative 8. If I cut that in half, I'm going to get negative 4. And if I square negative 4 times negative 4 is positive 16. So that's going to be the number that I add to the left, but keep in mind we want to maintain that balance, so we also want to add 16 to the right. So now on the left, if you look at that trinomial and you attempted an x box to factor this thing, you would find that it factors to be a perfect square. what multiplies to 16 and adds to -8 is -4 and -4. So I get x minus 4 times x minus 4, and I can call that x minus 4 squared. On the right side, -10 plus 16 is going to give me a positive 6. And so again, what we wind up with is something squared equals a number, and now I can take the square root of both sides. The square root will make the square disappear from the left side. It undoes the square, leaving me with x minus 4 on the left. But remember, again, as soon as that square disappears from the left side, I need a plus or minus symbol appearing on the right to take its place. And the square root of 6 is not a nice number, and there's nothing nice inside it except for 1, so I'm just going to leave that as square root of 6. And so now my last step to isolate the 6, I'm going to add 4 to both sides. And so I have x equals on the left. On the right, again, I'm going to write my relocated number first and then the plus or minus. So here that will be the 4 first, which was just relocated, and then the plus or minus square root of 6 last. And because 4 and square root of 6 are not like terms, one has a root and one does not, I'm going to leave them separate. And so here I have my two solutions, one that reads 4 plus the square root of 6, the other that reads 4 minus the square root of 6. I get two answers, which I expect because it was a degree 2 quadratic equation to begin with. Now, as we continue through these first several examples, I want to have you guys notice a pattern. When we add our magic number here, I want you to notice that there's going to be a pattern. I'll just keep calling your attention to it, of how we can factor without having to actually think of the X box and what numbers multiply to this and add to this. And here's the pattern. If we look to the middle on this trinomial, if we look to the middle and just cut that in half, that's what winds up in my perfect square. So let's notice that here. Let's make sure we recall that in each of the next few examples so that when things get harder, we can use that pattern, use that shortcut, that to factor and get the square, I just take the middle guy and cut it in half. That'll help when we have not so nice numbers later on. Let's take a look at another. For our first step, again, we want to make sure that there's nothing in front of x squared. In this case, I have just a 1 there, so I know that I'm good to start. When I start, I leave my letters on the left. I move my constant number to the right, so in this case, that positive 12 will relocate. Using subtraction, it'll move to the right. So I now have x squared plus 6x on the left, and on the right, I have negative 12. So letters on the left, number on the right, and this is the point where we complete the square. Our job is to find some magic number that we can add to the left to turn it into a perfect square. So the way I do that again is I look in front of x, I take that number, which in this case is 6, I cut it in half to get 3, and I square that to get 9. So 9 is going to be my magic number here. So again, you look to the middle, you cut it in half, and you square it. Now whatever I add to the left, I have to also add to the right. Be very careful to remember that. Now, by adding 9, I've created a trinomial, which if I factored using Xbox, I would get a perfect square. Let's just kind of think through it. I'm looking for numbers that multiply to 9 and add to 6, and I get 3 and 3. So this would factor as x times 3 times x, or times x plus 3. I get x plus 3 squared. On the right, negative 12 plus 9 gives me negative 3. And so again, I've created a scenario by adding the 9 to both sides where I now have something squared equals a number. So now I can square root both sides. The square root will undo the square, leaving me with x plus 3 on the left. Again, keep in mind that as soon as the square disappears from that left side, a plus or minus must appear on the right. And now the square root of negative 3 is not nice. There's no perfect square in it. The only thing I can do is take care of that negative. The negative under the square root tells me this is imaginary, so I'm going to pull out an I and leave just the 3 under the square root. Last step to get x by itself, I'm going to relocate this 3 using subtraction since it was positive. That leaves me with x on the left. On the right, I will put my relocated number first, which in this case is -3, and then after the relocated number comes the plus or minus stuff. And because the plus or minus stuff has imaginary unit and square root, and I can't mix that or combine that with a whole number, that's where I leave it. Again, the plus or minus is helping me see that there are actually 2 solutions. I have -3 plus I square root of 3, and I have -3 minus I square root of 3. Those are my 2 solutions. Before we go on to the next example, let's make sure that we're taking note of the pattern of how we go from this trinomial after we've added that magic number. How do we go from this trinomial to the factored form? Look to the middle number. Here I saw +6, cut it in half, and you get +3. So again, recognizing that now is going to be helpful down the road when we see harder examples. Let's take a look at another. Again, our first step when we're completing the square is to verify that there's nothing in front of x squared. Now in this example, there is a coefficient in front of x squared. There's a coefficient of 2. It's attached to the x squared with multiplication. What I'd like to do is I'd like to detach that 2. But the trick is, as with all equations, whatever I do to one, I have to do to all. So if I'm going to detach a 2 from this term, I'm going to have to detach a 2 from everything. Essentially, I'm dividing both sides by 2. So let's divide the left side by 2. Let's divide the right side by 2. And remember that it's not about who's convenient to divide by 2. It's I got to do every term divided by 2. So 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. -12 divided by 2 is -6. And on the right side, 0 divided by 2 is 0. So it's nice to get through that step. It makes all the numbers smaller, but again, the whole point is I don't want to see anything in front of x squared. I want to know that there's just an implied 1 there. And so now by dividing by 2, I've created that scenario. Now that I have nothing in front of x squared, I'm free to begin. I can leave my letters on the left, move my number to the right. So this 6 will relocate using addition to the right-hand side. Now on the left, I have x squared plus 2x. And on the right side, 0 plus 6 gives me 6. Now that I have letters on the left and the number on the right, I can add the magic number to complete the square. And again, the way I do that is I look to the coefficient on x, I take that number, I cut it in half, and I square it. So in front of x in this example, I see a 2. If I take 2 and cut it in half, I get 1. If I square 1, I still have 1. And that's going to be the number that completes the square. Make sure you're adding it to both sides to maintain that balance of the equation. Now let's see if instead of doing the x box, let's see if we can use our pattern to go from the trinomial to the factorization, because remember the whole point of adding this magic number is to complete the square. It's to create a square. This left side should say something squared. The way we figure out what goes in here is, well, I'm going to take the letter that I'm working with, x, and then remember I'm taking the middle term, that middle coefficient, and I cut it in half. If I take 2 and cut it in half, I get 1. On the right side, 6 plus 1 is 7. Now, if you couldn't do the shortcut or the trick, or you didn't remember the pattern, you still could factor this using a trinomial. 1 times 1 is 1, 1 plus 1 is 2. And so 1 and 1 are the magic numbers. X plus 1 times x plus 1 is x plus 1 squared. But if we can remember the pattern, if we can remember the pattern that we take the middle coefficient and we cut it in half to get that perfect square piece, that's going to be helpful in the next video when things get a little tougher. But now that I have something squared equals a number, we can now use the square root property. Let's take that problem up here where we have a little bit more room. So we have x plus 1 squared equals 7. Something squared equals a number. Let's take the square root of both sides. The square root will make that square on the outside disappear. Remember though, as soon as the square disappears from the left, A plus or minus sign will appear on the right. And the square root of 7 is not nice, nor does it have any perfect square in it, so I will just leave it as the square root of 7. And then my last step to get x by itself is to relocate this constant 1. Since it was positive, I'm subtracting it from both sides. And I wind up with an isolated x on the left. On the right, I put that relocated number first, followed by the plus or minus stuff. And because the whole number 1 and the irrational square root of 7 are not like terms, I just leave these guys separate, just like this. But I have two solutions again for that degree 2 equation. I have -1 plus the square root of 7 and -1 minus the square root of 7. So let's take a look at another example where we have to get the leading coefficient to be 1 before beginning. So again, before we can start the process of completing the square, we first have to make sure that the leading coefficient is 1. In this case, the leading coefficient is 3, so I can't start the completing the square process yet. I need to get rid of that 3. And since it's attached with multiplication, my first step is to divide everything by that 3. Make sure that we maintain balance by dividing everything on the left and everything on the right by that 3. So 3x squared divided by 3 will be x squared. Negative 12x divided by 3 will be negative 4x. 6 divided by 3 will be 2. And on the right side, 0 divided by 3 is still 0. So now I finally have the leading coefficient of 1. When there's nothing really in front of x squared, that's when I can begin the process. And in that first step, I will leave letters on the left and move the numbers to the right. So this positive 2 will relocate using subtraction. That leaves me with x squared minus 4x on the left. On the right, 0 minus 2 is just -2. Now that letters are on the left and number is on the right, now I can complete the square. I'm looking for the magic number that will turn the left side into something squared. And so to find that magic number, I'm looking to the coefficient on x. In this case, that coefficient is -4. I take that coefficient, I cut it in half, and I square it. So if I take -4 and cut it in half, I get -2. If I square -2 times -2 is +4. That's going to be the number that completes the square on the left, but I have to maintain the balance by adding it to the right as well. So now on the right, again, you could do an X box to try and factor this trinomial, but let's see if we can do the shortcut now. The whole point, remember, of adding this magic number is to complete the square. It's to create a perfect square on the left. I want it to say something squared. To figure out what goes in here, you take your variable, which in this case is x, and then you look to the middle at that coefficient. And to figure out what goes in the perfect square piece, you take that coefficient and just cut it in half. -4 cut in half is -2. And if you were to do an X box, you could confirm this is exactly what you would get with an X box. But the shortcut to get that perfect square is to look to the middle and cut it in half. Now on the right side, -2 plus 4 will give me +2. And so through this process, I now have something squared equals a number. So we're off to a good start. We have completed the square. We've created a perfect square on the left, and so now we can use the square root property to solve. We'll take the square root on both sides. The square root will undo the square on the left, leaving me with x minus 2. But again, remember, as soon as the square disappears from the left side, a plus or minus will appear on the right. And the square root of 2 is not nice, nor is there a perfect square in it other than 1, so I leave it. And then my last step to isolate x is to relocate this constant. So since I have a -2, I will add 2 to both sides. And now I have x isolated on the left. On the right, I'll write the relocated number first, that's the +2, and then I'll have the plus or minus term last. And I won't combine these because one has a root, one does not. They are not like terms, so I leave them separate. But again, I have two solutions. I have 2 plus the square root of 2, and I have 2 minus the square root of 2. I expected two solutions because it was a degree 2 equation. Let's take a look at just one more example for this video where, again, we're trying to divide to get the leading coefficient to drop off in the beginning. So again, before we can begin the process of completing the square, we do have to make sure that there's nothing in front of the x squared term. In this case, my leading coefficient is 2, and that's a problem. I have to get rid of it. So I'm going to divide both sides by 2. Again, I have to maintain the balance, so make sure we're dividing everything by 2, whether or not it turns out nice. 2x squared divided by 2 is x squared. 8x divided by 2 is 4. And 12 divided by 2 gives me 6. And 0 divided by 2, still 0. So I have now a leading coefficient of 1. And so I can begin. And I'm going to leave my x terms on the left. I'm going to relocate my number to the right. So 6 will relocate here with subtraction because he was positive. So now my letters are on the left. I have x squared plus 4x. On the right, I have a constant number, 0 minus 6, which is negative 6. Now that the letters are on the left and the numbers on the right, I can go ahead and complete the square. I'm looking for a magic number that will turn the left side into something squared. And again, the way I do that is I look to the coefficient on x. I'm going to take that coefficient on x, cut it in half, and square it. So in the middle, on the coefficient of x, I see a 4. If I cut 4 in half, I get 2. If I square 2, I get 4. So I'm going to add 4 to complete the square on the left, but I add it to the right to maintain that balance. Now, one more time, let's practice using this shortcut, because in the next video, it's going to be very important for us to be able to utilize this shortcut. If the whole point of adding this magic number was to create a perfect square, we can now use this shortcut for factoring. The shortcut will be to take that middle coefficient, cut it in half. So I will have x, and then taking positive 4, cutting it in half, I get plus 2. On the right side, negative 6 plus 4 gives me negative 2. So now I have something squared equals a number. Now I can use the square root property. So let's take this up here. X plus 2 squared equals negative 2. Something squared equals a number. So I will square root both sides. The square root will undo the square on the left, leaving me with x plus 2. On the right, I have to make sure that as soon as that square has disappeared, on the right I have a plus or minus to take its place. And now the square root of negative 2, it's not nice, there's no perfect square in there. The only thing I can take care of is that negative. A negative under a square root is imaginary, so I'm going to take an I out of that root there. So I'll have I square root of 2. And then the last thing, to isolate this x, I will relocate that positive 2 using subtraction. I wind up with x on the left. On the right, I'll take that relocated number first. Negative 2 comes first. Next comes the plus or minus I square root of 2. And again, because this is a nice whole number and this is an imaginary irrational number, I can't combine those. I leave them separate. But again, it's two solutions for that degree 2 quadratic equation. One solution says negative 2 plus I square root of 2. The other says negative 2 minus I square root of 2. Now, one thing to notice from the last several examples we've done, everything has turned out pretty nice. I've not seen any fractions, and that's actually interesting that I've never seen fractions because there's actually been a lot of division that's been happening. For example, at the very beginning of this example, when I divided everything by 2, it just so happened that everything divided perfectly. But what if instead of 12, that said 13? 13 over 2 would be a fraction. Same idea over here. When I'm finding my magic number, the way I found that magic number was I looked to the middle. I cut that number in half and squared it. But what if instead of 4 cutting in half, it was a 3 cutting in half? I would wind up with a fraction. So these examples were designed to come out nicely where there were no fractions involved. In the next video, we'll look at some examples where we do have fractions and see how to work with those.